Good morning, Chris. Welcome to ATC Office Hours. Thank you for joining me to discuss the Om246 report.
Yes, thanks for inviting me, Micah. Good evening to you, I guess. We're, I think, 13 hours apart, maybe?
I think so. In Bangkok, it's now 8 in the evening. So
Okay.
I suppose it's a bit colder there than it is here.
Likely, yep.
You-
It for those who might be watching around the world, it's -9 degrees here, and it's 16 degrees Fahrenheit. So kind of our coldest morning thus far.
Wow, yeah. I guess I should be able to tell that by looking at the scarf and
Yep,
the
the hat.
headwear.
Yeah. Right.
So we had tried the ATC office hours on the ATC Turf Discord server a month or so ago, and I think you were just getting ready, or you'd collected the OM246 samples, but you hadn't sent them to the lab yet. And it was actually your suggestion to say, hey, maybe we could do one of these again, and go through the report. And actually, I don't think we've talked in very much detail about the report. I sent it to you, you read it, but you've also
Yep.
been pretty busy with some end of season stuff, haven't you?
Yep, exactly. Yeah, I mean, we had kind of decided that we were gonna, once we were wrapped up season wise, we'd go over this report in detail and do something, maybe a Skype or something of this nature together. And then we thought, well, why not? Why not make that something that people could join in on and watch, or either live or recorded? Because I think as a superintendent, when anytime there's something new that you're going to do, like I'll go back to September of 2016 when you were here for the Ryder Cup, and we were talking about clipping volume, and we're getting ready for this event. And I'll never forget how you were like, "Oh, it would be really nice to be measuring the clipping volume from these greens this week." And all I could think, as getting ready for all this for this event, is, oh, I just can't, I can't make my brain think about that right now. And I think over the years, that's an extreme example, but I think over the years, I have found that every time I want to leap into something like this, it's hard to get over this initial hump of I don't really understand this, and I don't really know what it's going to do for me. But then once I jump into it and I do it, and go and start to see the results, or start to accumulate the data, then I really feel good about the decision to do it. So my point being that I think if there's anybody watching who has seen discussion on this OM246 testing, they've seen the hashtag, they've followed some discussions, they might think, hey, that sounds really interesting, but it's just something new and I don't know how to get started. So from my standpoint as a superintendent, I thought this would be great. I think it was your thinking as well, Micah. Let's expose some people to sort of what this data can mean and what this testing can show you. Talk about how we then change the way or manage the course because of it. And so hopefully it will be valuable to some people in that regard.
I hope so. And it's also, it's good because now you're 2 or 3 years into this, so we can look at a time series and also talk a little bit about some of the work that's been done to achieve that time series of organic matter change over time, or static organic matter over time, that we're going to look at really soon.
Right.
And how that relates to playability, and how that relates to how much work is required. So I think sometimes I get so close to this because I've been working on it so much and looking at the data so much. It's nice to have this type of conversation, just to talk about what we can really do with this. And I think the more people hear about this and learn about it, and once you start collecting the data, I mean, everybody's going to be like, why was I not doing this my entire career? And this is not something I invented. We're going to get started in looking at the report really soon, but here's something that almost very few people know, Chris. Who came up with the OM246 name?
I did, actually. And I'll never forget, I was sitting right here, and I was sitting right here at my desk, and you were sitting over there to my right at a table that's in my office. And this was during the KPMG Women's PGA Championship in June of 2019, which, man, that seems like a long time ago now. But in some ways it does, and in some ways it seems not that long ago. But a lot has happened since then. Anyway, I recall that you were thinking about this. You were talking a lot about this testing. I think we had not done it yet here, if I'm not mistaken. I think our first sampling of this was that fall. And you were talking about it, and you asked what would be a good hashtag for this testing. And I think I thought about it for a few moments, and I came up with this. And you liked it, so we went with it, and it is pretty catchy. So, if I had to pat myself on the back a little bit,
I'm forever indebted to you for coming up with such a great hashtag in only 5 characters, and it expresses this in a very pithy and easy to remember way.
I think it does.
So that's good. But as I was saying, I didn't invent this. I think we came up with the hashtag, but this is something that turfgrass managers in New Zealand and the New Zealand Sports Turf Institute have been doing research on this and testing since the early 2000s at least. So this is, let's say we're looking at almost 20 years at least of people in that part of the world doing this. I think on a similar timeline in the UK, because I know STRI has been doing this. All the Open Championship venues will have this type of data for their surfaces, and Charles Henderson specifically, who's now not with STRI, but when he was with STRI and then shortly after, he recommended to me. He told me that I should be doing this. It would change the way I thought about a lot of things, and he just said it would be a great thing to do. I need to get started with it. And as I am with some things, I'm very slow to appreciate the value in that. And so it did take me quite a while, and it wasn't until 2016, 2017 that I really started doing some research into this. And then by the summer of 2019, I was ready. I'd already done enough research that I was really comfortable with the burn temperature, with the sample size, with leaving the grass on the sample for putting greens, and just ready to do this. And so that's why at the 2019 US Open at Pebble Beach, I was talking people's ears off about this. And then the next week I was with you, but at the KPMG, and that's when we came up with the hashtag. So,
well, yeah, Om246 was to the 2019 KPMG what clipping volume was to the 2016 Ryder Cup in my mind.
Yeah, that's good. Golf tournaments are great for talking about those kind of things.
Oh, they sure are. They sure are. And yeah, I mean, you and I have had many of those discussions over the years at various tournaments. So it's I'm sure anybody who's followed you on Twitter or spent time with you at a golf tournament can relate. So.
Yeah, and speaking of Twitter, you can follow Chris on Twitter at CT_turf. All right, Chris, should we jump in and start looking at the report?
Yeah, let's do it.
Okay, so I'm going to share my screen, and that pops us there. How does this look? No, it's bigger this way. Okay, I'm gonna show it like this, and I'm gonna scroll down to the first chart. So there's some I put a table of contents, and then I put a lot of text that I'm not gonna go through the details right now. We may flash back to that, but let's just go to what I think is the meat of the report, which is the actual results, the time series. So, Chris, you actually had done a tentative, like a research sample for me in May on May 15th of 2019.
That's right.
And
I
then,
couldn't remember that first date.
mhm,
And I seem to recall it was that fall, but I forgot that we had done the research sample
mhm,
early before that tournament. Yep.
that's right. So you've got from spring of 2019, then you've got, so you kind of have a guess through that 2019 growing season. Then you have a full set of data from autumn of 2019. Then you have all through the 2020 season, another sampling, and then another. So basically two full seasons, and then that first year we have a limited amount of
Yep.
data.
Yep.
So I'm going to check in the chat. I think if anybody wants to chat, I'm I'm running this through Restream. This might be live on Twitter. I'm not sure. I think it's live on YouTube. So I think if you leave comments, they are supposed to show up in my Restream here, which I can see on my screen. So if anybody has questions or comments that they want to leave, you can go ahead and type them in, and I'll try to answer them. So Chris, the thing that I put these charts first, I think this is the most important, is TJ, thank you. TJ says chat test. The cool thing, we can even show this on the screen if
Yeah,
they're
that's
really
cool.
That's cool. So
that's big commitment from TJ. He's up early here.
yeah, I was thinking that's like 5 a.m. for the guys on the West Coast.
Yep.
And I think our friends in New Zealand are hopefully asleep. I don't think they're up yet in the morning, but I'm glad that by doing this on YouTube, this will be recorded so people can watch it in the future. All right, thanks, TJ. All right, everybody, thank you, Antonio. We've see that okay also. Awesome. So this pops right up. Cool. So these, I think we don't have to worry so much about the exact number. Okay. I'm seeing that you had 4.9% organic matter. That means by weight, there were 49 grams of material burned off, which we assume would be organic matter. 49 grams of material burned off per 1 kilogram of soil material. So that's 4.9%. That's what you were at on the samples taken in October 2021. And it was exactly the same in October of 2020. So when you got these results and saw that at the 0 to 2 centimeter depth, that it was the same year after year, were you pleased with that, Chris?
I was. And so, last year was the first time in which we went over these results, and you sort of gave a prescribed amount of sand to apply for the next 12-month cycle. And 12-month cycle would be from the time I take one test to the time I take the next test. So basically October of 2020 to October of 2021. So that cycle would include any top dressing that we're applying, getting ready for winter, and then anything that we apply in season. So with last year's report, we had talked about an amount of sand to put down to maintain that level. Because you're right, that has been our discussion, is not say, okay, we're at 4.9%, let's try to get to 2.5%. But that we're at 4.9% now. You say to me, tell me, how did the surfaces perform? Can you get the green speed you want? Is the firmness the way you'd like it? Are you getting infiltration the way you would want it? Are you having any sort of issues with anything else? And my answers are really to those questions, no. So then you say back to me, okay, that seems like you've got a great surface, a surface that is producing what you want. So let's keep it there. And then the amount of sand prescribed is meant to keep it at that level rather than try to drop it to some level. And I think that accurately describes it.
Mm-hmm. That's what I think every golf course should be looking at first, is how their surfaces are performing and how the organic matter is changing over time. And
Yeah.
because we're concerned about how the rollers on a mower roll across the surface and don't sink in, we're concerned about how the golf ball reacts when it
Yep.
lands and hits the surface. So
Yep.
if we want those to be satisfactory, and that could be satisfactory at 2, at 3, at 7, at 12, it could be satisfactory at a number of different organic matter levels. Now, in the next chart that we look at, the second chart that I show on the report, we sort of compare to what's normal for that particular species. But I think rather than first looking at what's normal for a particular species, I want to consider how the turf is performing, how the surface is performing, and look at whether there is effective how should we say it? If the work that's being done has been effective in creating that surface and moving the organic matter or keeping the organic matter the way that you want it.
So I think that's a key to all of this is that if I were to just say you have to have other metrics to tell you that you're happy with 4.9%. And so Mike, I think, can I just go ahead and share my screen here for a moment?
Yeah.
Let me do that, and let me show you just kind of our green speed data.
Yes, please. I hope you can share. I hope you're able to share the screen.
Let's hold on. I should be able to, but let me just adjust a few things here. Okay. Okay. Here it comes.
Okay.
You see my screen?
I see it, and I'm gonna now add that screen to make that live. Okay.
Okay.
There's Chris's Google Sheets.
So this is all of the green speed data for the year that I record. Most of the time this is me. Sometimes it's the assistants. You can see most days it's the whole numbers are going across from the left to the right. So you can see there's just, I take a lot of green speeds on a lot of days throughout the course of the season. Now here's what I want to share is the graph showing these speeds and the 7-day average of these speeds. And I think that this is really important because if I were looking at, because this tells me is 4.9%. This is one of the data points that tells me is 4.9% getting us the results that we want. And so if we look at this, this is about the middle of June. And you can see our average speed kind of climbs above 12 and stays there until we did an airfine event in the beginning of August. And then it falls down as one would expect. But so the point is that through the middle of the summer, the peak summer season here at Hazeltine, we're able to maintain a green speed that our members desire. And the point isn't that saying you should be above this number. This is going to be course specific. But if you're maintaining the level of speed that you and smoothness is another thing that goes with this. Let me show you those data. So here is data from a smoothness rating that I do every day, the STRI smoothness rating. Michael, we can maybe talk a little bit more about that. I know you blogged about it a little bit. Maybe you can share links or something. So
yeah, I actually have one of your bobble test charts kind of queued up to share later, possibly.
Great. So this is just that data, and I take that every time I stimp, and I watch how the ball rolls. And I don't have a chart that goes with this, but this is just the data. So we'll talk about that. But to me, when you look at green speed plus the smoothness is telling me, are we getting what we want from these surfaces? So that's a quick way to just check that you're, so let's go. Okay, I can stop sharing now, Mike. We'll go back to your your charts. The point in showing that is you have to know, you have to have a metric or data points, I think, that are telling you if you're meeting the goals of your clientele. In our case, our members, and a public course, it's the case of the people who are coming and paying green fees. So then we can go back to 4.9% organic matter in the top 2 centimeters and say, yep, that's a number that we can stay at and we'll be happy with.
Awesome. Thank you. Thank you, Chris. I, I, I agree completely. And I guess I've done a blog post about this also where I said, I noticed something as more and more people do this test, for the first time, a lot of people get results that are like 7, 8, 9, 10, 11% organic matter right at the surface. And, and yet the surfaces are performing well. And if you look at different greens on the property, the healthiest greens always have the most organic matter. So, guys will get like, 7%, 8%, 9% on their samples. They'll submit 6 samples, get a range like that. And instantly the reaction or the response to me is, I want to reduce this by 2% or reduce this by 3%. But I look at it, I'm like, wait a second, which is your healthiest green out there? And it's often the healthiest green, almost always the healthiest green has the most organic matter. So then it's like, wait a second, why do you want all the organic matter to go down to the level of your worst green? So let's think about what we're doing and think about maybe just keeping it stable, so things don't get softer, so they don't hold too much water at the surface.
Yep.
So this is,
So in this chart, as you say that, these outlined circles are the individual measurements. And I would say, and I know this, it's not the way that we look at this data, but I know which ones are which. And I know that our healthiest green is this top circle, the highest OM in the 2 centimeters. And our least green that struggles the most is the lowest. That's 100% true. And I sampled those 2 greens purposely to be able to look at that.
Chris, this would be a good time to answer a question from TJ.
Yep.
Eric, I see your questions, and I'm going to answer those later. But TJ was just asking about the average. He said, how many greens are you sampling to determine that average number? And Chris, I'll answer for you.
Sure. Yep.
You did what we're looking at here, the average number at the OM2 depth, the 0 to 2 centimeter depth, that's 6 greens, if I remember correctly. And then
That's correct.
Definitely the 2 to 4 centimeter depth and the 4 to 6 centimeter depth, those are 3 greens, because it tends to be a lot more consistent at once you go just the tiniest bit below the surface, it's more consistent. And I don't think it's necessary to pay lab fees to just keep getting the same number over and over. So I recommend spend a little bit of extra money to sample a few more at the surface. That's where the ball's reacting. That's where the mower is rolling. And that's where I think we need to be a little bit more precise.
Yep. Eric asked a similar question. So the question that he asked, are you sampling 3 at 246 and more at 0 to 2? And that's exactly it. Yep.
That's right.
6 greens are in the 2 centimeter average, 0 to 2, and then 3 greens in the others.
Yep. That's what we're doing. So I generally recommend to do 0 to 2, 2 to 4, 4 to 6 centimeter depth on 3 greens, and then do an additional 3 greens just at the 0 to 2 centimeter depth. That's generally what I would recommend.
And I think we're going to move on from this chart, Micah, but before we do, I think just a statement to those watching, like you and I aren't really discussing the 2 to 4 and the 4 to 6. We look at that. Nice to have, good to have that information, see if anything's changing dramatically. But there's no real intent to use those numbers to change anything at this time.
That's right.
Yep.
I would suggest to everybody to look at the 2 to 4 centimeter depth and see how that hasn't changed over time. And yet, you did a dry jack this year. Last year, I don't think you did any. I don't
Last year
remember.
it was a solid tine filled with sand.
Okay. So
Yep.
just doing what we would call relatively minimal amount of holes and getting sand down below the surface, and it's still staying pretty flat. And then it is coming up at the 4 to 6 centimeter depth, but we'll look at the next chart and see that that's nothing to be concerned about. In fact, I mean, organic matter is a good thing, so we could say that's just the root zone's getting better and better for grass to grow.
Yeah, that's, these are USGA greens. I don't think we've talked about that. They were built in 2010, so they're 10 years old. A USGA green, some people consider that to have about a 20-year lifespan, 25 maybe, 30 maybe. So we're, approaching 1/3 to 1/2 of what many would think would be the lifespan of a USGA green. And one thing that I have noticed, not to get too far off track, but Micah talks about organic matter being a good thing, is in a USGA green, you don't see this tremendous rooting depth. We have 3 greens on a south chipping area, practice area, that are not USGA. And when you pull a plug out from a cup, the whole thing, the root mass is the whole plug. But when you pull a plug out from a USGA green, you have really great rooting up in the top. But let's say in the 0 to 6 centimeter range. But below that, there's really nothing. And I think that probably has a lot to do with the amount of organic matter that's down there. So, yeah, I would say building it up a little bit in the 2 to 4 and the 4 to 6 is not going to be a long-term problem.
Very, very good. And Eric has another comment here, which I agree with. I'll show that comment. He thinks that more samples at the 0 to 2 centimeter depth, given that the 2 to 6 centimeter depth remains largely unchanged in his sampling. So Eric's at Chambers Bay in the state of Washington, and I've done this type of sampling at different continents, different countries, different grass types, and it's pretty consistent that you tend to see very little change over time at the depths below 2 centimeters, which I think there's all kinds of implications for that. But the obvious one is how necessary is it to punch holes and remove material from down below, or how necessary is it to punch holes and put sand down into those holes at that depth below the surface for the purpose of managing organic matter. Now, there may be some other reasons for doing it, but for the purpose of managing organic matter, it would seem that it may not be necessary. Can I, let's go down to the fancy chart, TJ's
Yep.
favorite. All right, so I get to make these reports and I get to put the ones that I think are most important at the top, but this is the prettiest one and the fanciest one, and TJ thought this was pretty interesting. This is my favorite one. We're showing some density curves of all samples of that particular species, and then we're showing percentiles of how your most recent samples compare to what's normal for those particular for that particular species. So here we're looking at bankgrass greens, creeping bankgrass greens.
Do you think, Micah, that again, getting to the idea that, well, let me ask, I'm trying to think of how to ask this question. It's been easy for me to understand the fact that I don't want to chase some low number. So when I look at these charts and I look at 0 to 2 and I see that we're at 4.9 and that 29% of golf courses are below us, it would be easy maybe to think, oh, like that is a number that we need to get to. We need to get to the point where only 10% are below us, and I need to chase this 2.4, this absolute. Do you find, and maybe not, maybe people that you work with understand sort of the idea of keeping it in a range that's good for that particular course, but do you fight that with anybody you work with where they want to chase this low number? Or, how do we talked about it a little bit, but I wonder how we get away from that idea.
Fortunately, I haven't had to deal with that particular issue yet. And if somebody did want to go that low, I would say that I don't recommend it, because once you start going to the tails, we've talked about whether the word margin should be used or tails, but this type of curve, I would call it a tail when we go to the left or go to the right. Once we start going there, you realize there's not very many bentgrass greens at 2.4%. So that means there's not very many good performing bentgrass greens at 2.4%. So then it's like, no, so that's the type of thing that I would try to explain to people and just say, please try to keep it closer to the middle. I mean, if that's what I would be trying to do. So now I kind of assume that everybody knows what this test is and why we're getting a number like 4.9% and saying there's only 29% of bentgrass greens are expected to be below that. This is a test where we're not measuring soil organic matter the way that testing for soil organic matter is defined. Soil organic matter is defined by the Soil Science Society of America in their glossary as the organic material in the soil that excludes any living or dead undecomposed plant material. Now, that becomes problematic when you start looking at samples that might have thatch or mat in it. And on a golf course putting green, we want to know what's happening with the thatch and mat, because that's what so much of the top dressing is done to manage. That's what so much of the coring, verticutting, dry ejecting, and so on is done to manage. And the problem is conventional testing is more for soil nutrients, for the humic material in the soil, and it removes all of the thatch and mat before testing it. What the Om246 test does is measures everything, and that's why we get a number like 4.9% and think, yeah, that's relatively low. If this was a typical soil organic matter test, we'd be thinking that it would be something like 1.5%. But we're measuring here everything, which I think is one of the beautiful things of this test.
Yeah, and somebody might ask, I'm just looking quickly to look at our soil nutrient report and see, because if somebody out there is watching this and thinking, well, how does that translate to the soil organic matter as I want to say normally, that might, as people would normally hear it. So soil organic matter from a normal soil nutrient analysis test.
Yeah, you'd be
for these is one average of 1.5%.
1.5. That's very normal. And when we did the global soil survey, which had 100 samples from putting greens, from explicitly good performing putting greens from all over the world, the average value for organic matter in that, which goes down to a 0 to 10 centimeter depth and screens off all of the undecomposed living and dead plant material, the average there was 1.6 for putting greens. So that's one kind of organic matter. This is something different. This is total. I say organic matter sometimes, and sometimes I say total organic material. So that's awesome. Like Hazeltine National Golf Club is a tournament venue, and I know it's renowned for having a very active golfing membership with really competitive and find players. And so I
Yeah.
think it's kind of normal for me to say, yeah, I kind of like you in the lower percentile, because that means you should be able to dry the greens down and get a nice firmness and be able to control the moisture and so on. So I look at that number and it's just like, yeah, that's nice. And then we try to figure out what work should be done to keep it that way.
Yep. Would it be worth touching on, because one of the things I think you and I have both heard and is a focus when it comes to putting surfaces on infiltration rate, and there may be people watching who are wondering about that and wondering, if we look at that or how this might relate to that. Should we touch on that?
Yeah, I'm happy to. I did a blog post earlier this year. So if you go to asianturfgrass.com and search for infiltration rate, you can find my comments about that and citing some research articles that said it's something that you may not need to worry about so much. Obviously, that is critical to having a good performing putting surface, because if your infiltration rate is not rapid enough, then your surfaces are going to be too wet. I think that that's something you can see with your eyes when it rains or when you irrigate. And the other thing is you can measure soil moisture over time. And if you consistently see that after saturating rain events or after irrigation events that fill the soil to field capacity, if the field capacity number that you're measuring with soil moisture meters keeps going up and up, that to me tells me you have a problem with infiltration rate, or if you see puddling or something. But I don't worry about measuring it, because I think it's quite difficult to measure, and it's like chasing after numbers that seem meaningless to me. I mean, that's my thought about it. So I'm like, obviously it's critically important,
Yep.
but I don't want to measure it. I want to see it and feel it.
Right. And
I don't.
to me, it's a part of that group of, and there may be no data. I don't have a chart that shows it because we don't really measure it, but all of the things you just said, our observations are telling us whether that is something that's a problem. And I don't see that it is. We can get lots of rain, and while the greens might puddle or have surface water on them initially, like in a downpour, as soon as the rain slows or it stops, it goes away very quickly. I mean, in the amount of let's say in the amount of time that it would take, let's say there's a downpour that stops play. We're going to have the U.S. Amateur in 2024. So let's say the players are out there, and a lightning comes in, and the players are removed from the course, and we get a downpour, and in a course of an hour and a half, we get 2 inches of rain. There may be water that shows up on the surface. There may be some brief, but by the time the players would go back out to the course to play, that would be all gone. And I mean, to me, that's playing. I don't need 100 some inches per hour or whatever a USGA green is built at, because that's just almost obscene and unnecessary for the way that golf is played. So.
Yeah. So yeah, this is a question that some people have about infiltration rate. So thank you for bringing that up. To me, it's not really related to this, because here we're just looking at organic matter, and I'm assuming that the more organic matter, the more organic material we have in the in the soil, the more water it's going to be able to hold, and based on how much water it can hold, that's also going to have an effect on how firm the surfaces are. So I'm looking at the criteria here being how firm or soft the surfaces are, and how much water it's holding. And I think infiltration rate, if the surfaces are constantly too wet, the infiltration rate is not fast enough. It seems obvious to me. So I'm just like, let's solve the problem that way. Let's solve it the easy way, and not try to inflate some kind of numbers. If that
And it
makes sense.
probably, I wonder, I'm going to share my screen one more time, Micah,
Cool.
and talk, because I do measure firmness as well. And that's something we're measuring on a weekly basis, and measuring on 3 of the greens in which we do our 246 sampling. So here we can see this is a scatter plot of, we use a Clegg hammer.
Okay,
An
I'm
older,
gonna share.
yep,
I just see that. There we go.
Okay, so here, this is a scatter plot, and the firmness is over here on this side, and this is the number that comes up on the particular Clegg that we've been using. It was, I'm borrowing it from Doug Soldat in Wisconsin, and then this is the moisture, average moisture. So I go out to these greens, these 3 greens, and I take 9 spots. I take the moisture, and then I take the firmness from the exact spot that the moisture was taking, and I write it down, and then I input that data over here on the left, so you can see that. So this is the average. This scatter plot is the average of 883 different samples during the course of the year on across these 3 greens. This is a scatter plot. Whoops, where did it go? Right here, of every single measurement. Just, that gets to be a little blobby, but nonetheless. So these are the averages. So each day that I would go out and take these measurements, which ended up being 27 per day, 9 per green on 3 greens, this would be the average. And so again, this is another data point that's telling us if the organic matter that we have in that top 2 centimeters is something that is acceptable. If this line were, Micah, do you want to talk about your knowledge of charts and such is far greater than mine. So if you want to.
Right. So that chart is showing that there's not a perfect relationship between soil moisture and how firm the surfaces are. But with that particular meter, the higher the firmness level, the more firm the greens are, the higher the number will be. And what you see, because that line goes down from left to right through those data, and actually your other chart is even more clear about that. If you scroll up to the jumble of points, you can see that it's not, all the points don't fall on a line. There's a lot of scatter around the line, which means you can have greens that are a little bit drier and soft. You could have greens that are a little bit wetter and firm. But in general, what that's showing is that the surfaces are more firm when it's dry, and then they soften up a little bit as it gets closer to field capacity. But it also shows that it never gets so wet that the firmness gets too that it gets too soft. So it's what you'd expect for a place like Hazeltine.
Now, it'll be interesting as this data gets collected year after year. I would come back to these charts, and tell me if I'm wrong, Micah, but I'd look at it and I would say, is there some sort of like drift that takes place? And one would think that as you get to, like, if you can stay around 4.9 to 5% or somewhere in that region, you're going to get similar results year after year. But, having this info, it will tell us, is there some sort of, are we drifting to firmer, or are we drifting to wetter, drier, firmer, softer? We'll have that info.
Yeah, I should have Andrew McDaniel on here sometime, and hopefully he will join me, and we can look at an even longer time series of this type of data from Keia Golf Club in Japan, where we have data on firmness and soil moisture and some other playability parameters from 2013 up until the present. And it's interesting. I never would have thought that it would be so valuable to have these data and look at it year after year. And for Andrew, it's for a professional tournament that they have the last week of August every year. And so he doesn't have the full set of data for the entire year, but he has it for just 1 week in August for the past 9 years or so. And it's tremendously helpful to be able to adjust the maintenance work to prepare the surfaces for the tournament year after year, and to see that firmness keep going up, and to see the green speed reaching the target level and then just staying there year after year. It's pretty cool. And a lot of the OM246 stuff came because what Andrew realized on those zoysia greens was they grow so slow that they don't really recover well from the type of intensive maintenance work that I was recommending. I was telling him they have too much organic matter. You need to make it firmer. You should be punching holes, putting sand, punching holes, putting sand. But if he did that, he's got a tournament the last week of August. He couldn't really have the recovery time that he wanted and be able to slow down the growth of the grass to get the green speeds at that time of year. And so he kind of moved away from top dressing so much, moved away from punching holes. And I supported that because the surfaces kept getting better and better. And the fewer holes he punched, the firmer it got. But at the same time, I was quite concerned. This is in 2015, 2016, going into 2017. That time frame is like, man, we need to be really careful that there's not something happening under the surface with organic matter accumulation that we're not catching. And because it could be all of a sudden it rains during the tournament and everything was all perfect, and then all of a sudden your mowers sink in and scalp, and it's like, oh, I guess we weren't making such a good decision about skipping all of this work that the textbooks say that we should be doing. And that's when I turned to the OM246 testing and was like, I really need to do this, because I realized that the testing that we were doing otherwise just for nutrients was discarding this material that we wanted to measure.
It seems to me that anytime there's a discussion when it comes to golf maintenance of golf course putting surfaces, that the fear that any manager, golf course turf manager, has in reducing what they're doing, no matter what it is, no matter whether it's some kind of cultural practice, some kind of watering, some kind of nutrient application, potassium. The fear is of some sort of unintended consequence, some sort of, I remember I was talking about our lack of potassium applications at GIS a number of years ago. I mean, this is 5, 6, 7, 8 years ago or so. It was in Orlando a number of cycles ago. And one of the questions that somebody from the back of the room asked was, don't you fear that your turf is moving towards imminent collapse or something of that nature? And that, at some point there was just going to be this, I was going to walk in, leave one night and the golf course was going to be great, and come in the next morning, the golf course was going to be dead. I don't think any of these things work in that way. And that to me is the key. If you look at data, you think about collecting data, and I know when people hear about it who aren't doing it, they think, oh my gosh, what a hurdle to get over, and what am I going to do with this? But what it's doing is it's confirming and allowing for us a reduction of some of the things that we thought were necessary to maintain a good golf course. We've been able to reduce those items, minimize them, do them the least amount possible, and have the data to tell us that we're not in any danger here. We're not creating undue harm.
Chris, I think this would be a great time to answer TJ's question. He said, can you talk about the practices that allow you to sustain these levels and speeds and smoothness?
Yep.
And then he said specifically like top dressing events, annual depths, needle tining, things like that.
Yep. So let's I'll stop sharing mine. Like, I don't know if we'll go back to your charts. Let's go back. I think those will be more relevant to what I will
Do
talk
you want me to
about.
bring up the chart of the smoothness that has your
Yeah,
top
let's
drip?
bring that. That's a good one. That's a good one. Yes.
Okay, so I think I can stop sharing this screen, and then I think I can share a different one. Right. Um, so now here's our bobble test chart. And so I
Yeah,
think,
excellent. This will
so
be
you,
great for this discussion.
so this one was only updated through like early September,
Mm.
but you didn't do any more events until the end of the season. So this allows you to show what you did this year.
Yep. Yep. So let me try to explain how I've thought about course maintenance and cultural practices over the last, in general, I've always felt as a superintendent, I want to do the least possible to the golf course to get the best possible results. So our results and what we desire are at a high level. And then to do that, I think, okay, what is the least amount I can do to get to that level? And not do anything that isn't necessary. And so a story from the 2019 KPMG. This is when I started to sort of realize, let's use top dressing as an example. Okay. It's very normal in this industry to top dress on a regular basis, every week, every 2 weeks, every month. And now let me just disclaim this by saying, I'm not suggesting that this will work in every situation, but it works for us. And this is just how we think about it. So I'm not telling you, if you're managing Ultradorf Bermuda, this is going to work for you, or if you're managing POA, this is going to work for you. But this is what I've found works well for us. So put that filter on this information, and then use it to your advantage. Okay, so in 2019, we come out of winter. The KPMG, the women's PGA, is the third week of June. We come out of winter. We had a tough winter with a lot of ice that year, and our greens were a little bit. We had suffered, I don't even want to call it maybe a little winter kill on some north facing slopes where we had some ice. This is even on bent grass. And so we come out, and it's the turf is slow to recover. And then we had a really cool, I would call it cold spring leading up to that event. We have A4 bent grass, which anybody who has it in a northern region will know it grows and greens up very slowly in the spring. So we had all those sort of things working against us. So the PGA of America gets here, and we start working on getting the course ready. We're about 10 days out, and the greens are just a little bit bumpy, a little bit not as smooth as we'd like. So we decide to top dress, and it's a little bit closer to a tournament than a person would typically top dress, but that was the right call at the time. It really did improve the greens. And then we actually did it one more time, I think just 3 days before the practice round started. And that was all fine. The greens were great. Michael was there. We were, he was helping us stimp, and we were looking at smoothness, and the greens were really fantastic. But we were mowing and rolling, double cutting on turf that was just sort of like really waking up, really hadn't gotten a chance to sort of grow and form a great surface early in the year before we started doing all of that work. Plus, there's this sand on there that we're constantly rolling and mowing over the top of. Then we go into our normal season, and about a month after the event, 3 weeks after the event, we're going to host our invitational. And I decide, as I normally would, about 10 days before that, we're going to top dress, because that's kind of the routine. And we did. And then it got really hot, and we had our event, and we did a lot of mowing and rolling during that event, and the greens just declined after that event. And a lot of it was just this, looking at them, this was this physical damage to the leaf that, those of you who maintain bent grass during the summer will know, if you damage bent grass or get any kind of like physical damage to the leaf tissue, the plant just declines really quickly. It's not very traffic tolerant is I guess so Then we go into 2020, which is of course a pandemic year, and for various reasons, short staff, this whole top dressing and decline of the turf in the back of my head. We come into the spring, and it gets to be to the first time of the year where we're going to top dress, and I think, what if we just skip that this year? So we skip it. We have a tournament. Greens are great. Collecting all this data, collecting speed, green speed, clipping volume, all that, and everything's great. Okay. Then we get to our next tournament event, and we're ready to top dress. And I think let's not do it. The greens are great. They look, the smoothness is great. The speed is great. Let's not top dress. So we go through the whole golf season, never putting any sand down ahead of events. There was no bi-weekly top dressing, monthly, weekly, whatever it was. We just lived with the sand we had put down going into winter until we got to our aerification date, which is at the beginning of August. And the greens were great. We aerified, we grew out of that, and we didn't put sand down again until we were closed for the year. So this got me to thinking that I think we don't, these were the best greens we'd had since I'd been here, and it was the least amount of sand I put down in season. So now my mind is thinking, okay, there's some amount of sand we need to put down, but let's think about what the windows are going to look like for putting that sand down, and what is the actual real amount of sand we need to put down, not just some arbitrary, light dusting 2 times a week, and it builds up to whatever it is. But let's find out what that amount really is, and then put it in the smallest number of windows possible so that our golfers and our surfaces are impacted the least, as little as possible by that sand. Because I've seen, and you can see now, we're going to get to this this chart of the bobble test and the smoothness rating. I've seen when you put sand down that there is a decline in the smoothness of the surface and the quality of the surface. And over the years, just sort of anecdotally, I have heard that from our membership who didn't like the sort of roller coaster of surface quality that took place when we would top dress and then build back up, and then top dress and build back up. They didn't enjoy that. So, I'm really trying to create a surface that replicates a championship event for our members for as many days as possible during the course of the season. And because we're closed in the winter, we open about April 15th and we close just about Halloween, that period of time is quite small relative to places that are open for longer or open all year long. So, that's our goal. That's sort of the overriding goal and experience that I want to give our membership. So if you look at this chart, maybe Micah, do you want to just explain this chart a little bit? Again, your explanation of charts is far better than mine. So,
all right. So this is another one that's on my website. If you search Bobble Test, BOBBLE, search that on my website. You can pull up this post and read about it and study the chart at your leisure. This is quite an interesting one. I don't remember if I recommended to Chris to start measuring bobble tests this year, or he told me that he was going to. Maybe I was thinking we came to the same conclusion. It would be a useful measurement to have.
Yeah, I think somewhere there was a discussion involving you, potentially Jason Haynes, about this test, and we talked about it. And we thought this seems like a good combination with green speed, and it's easy to do. I'll let Mike. I can explain how I take the test. It's essentially, this is a visual rating, and when I stimp the green, I watch the ball roll across the green, and I give it a rating on a scale of 1 to 10, and I give it a rating on a scale of 1 to 10 as the ball rolls across, and I watch for the ball chattering across the surface. I watch for any big bobbles that the ball might take across the surface, and I watch for any sort of snaking that the ball might do. So as the ball rolls, and you will roll 3 balls as we stimp, I'll rate each one, and then I'll add those numbers up. So if it's 3 9s, it's a 27. If it's 3 8s, it's a 24. And that's how I get this rating. So then I put it in my spreadsheet, which I shared before, as a 27, a 26, a 25, whatever those three ratings would be added up, and then the spreadsheet, I have a formula that averages it all out to give a bobble test score across all of the greens that were stimped that particular day. So that's where this number comes from. So you can see, even though it's a scale 1 to 10, we had a 6 in here. That was right after we had dry jetted, and there was a lot of sand and so you can see in a northern climate during the season, you're really not going to go below 6. But so Mike and I have talked about it, and he has this dotted line across 8. 8 is really when a golfer putts a ball. If you have an 8, the golfer is going to deem that to be nearly perfect. 8 is a really good score.
Right. So this is showing through the season, starting in early April at the first mowing. So this, the first asterisk down there by April 1st, that's the first mow of the season, which was on April the 6th this year. And it started off a little bit below 8, but quickly with mowing and a little bit of rolling, that average every day got up above 8, and it stayed there until a heavy sand top dressing on May 11th. And on May 11th, that's the second asterisk. So that was a top dressing of about 0.8 millimeters, which would have been, that's about 3 cubic feet. That's about 3 cubic feet per 1,000 square feet.
I sort of deemed that when I put down that 0.8 millimeters in May, that was with no holes. So that was just sand on top, dragged in. To me, that was about the limit for our situation of sand that I would want to put on without having any holes or anywhere for the sand to go. That was pretty heavy on a surface to then send golfers out to play on.
And then after you do that, you can't roll as much as you want to because you would just beat up the grass. So then it's keeping the value down a little bit. So it took a couple weeks to get back up to 9 where it was before the top dressing. And then it got so good where it was above 9 every day that you just stopped measuring it, and you were only going to flag it if something happened. Right. And so you went for all through the peak season up until early August, right up above 9, which is basically perfect. And then you did the dry eject in early August, and after that it took a couple weeks to get back up above 8 consistently.
Yep. And this chart stops in about mid-September, but it does go, I don't know if my pointer shows up on the screen, but it does go up above 9 right after this, and then stays above 9 for the rest of the season until we closed.
So this is the kind of thing that Chris said it very well. This may not work everywhere, but I'd always been using the example of Kea Golf Club and what Andrew was doing and achieving with those core eye greens with basically 2 top dressings a year and not punching holes. And I think it's intriguing. And I always say, okay, it may not work everywhere, but it certainly works at this place. And to see this type of thing happen at Hazeltine also, where you basically in season put sand 2 times this year and have spectacular results. I think it's exciting because it suggests that now there's 2 courses in the world that can do this. And I know there's a lot of other people out there that are doing this, getting great results, and they know that we haven't discovered anything new because they already know this. But definitely there's a mainstream type of management style that I used to teach in seminars. I used to write articles about it and tell people they needed to put more sand out. And I know there's a lot of people that kind of teach what the standard way should be, and what you're doing is not quite the standard way. And so that's why it's always risky to do things in the non-standard way. And I think that's where there's a tremendous value in the Om246 testing to measure what's going on. And not only does it tell you that maybe you don't have to do so much, if you're not doing enough, it's going to tell you that too. And in fact, I answered some questions today about an OM246 report for somebody who'd done it for the first time, and I recommended trying to bring the numbers down a little bit. So I calculated how much sand should be applied next year and said, that's what I would recommend for next year. Let's see if we can drop this a little bit.
Yep. And we, even our report, which we hadn't gone over, and I don't know that we need to, but we have, I had mentioned earlier, these 3 greens that are on the south end of our practice area. They're practice greens. They're not USGA greens. They don't have the same construction as our course greens, but our members have asked that they represent or are more similar to, when the ball lands, are the greens that we have on the golf course. And so we tested them this year, and they were part of our testing regime. And then you gave a recommendation, Mike, on what you think we need to do to those greens next year, over the next few years, to get them back into the range, or get them closer to the range that the course greens are at. So,
and those, if I remember right, they needed a couple more millimeters of sand.
I think we talked about 3 potentially. I think your recommendation might have been 3 times the sand depth that we're going to do on the greens on the course. So
something like that.
Yep. There's a question from Carl.
Yeah, let's answer all the questions now, and then talk about how our time's going, and if you want to continue. Sure. Why don't you answer Carl's, and then we'll answer Eric's from a while ago.
Sure. So I think just to can you put, there we go. So I spoke a little bit about this, but it is a good point. The perceived risk of not doing things that are normal, or not doing things that are traditional. And the idea that if we don't do those, bad things can happen. So I think one way to think about that is, and I don't want to say anything that's going to be offensive to any of our members, but look, members vote with their feet, you might say, or they vote with their eyes. In that, what I mean by that is that members vote by the conditions. They, if the conditions are good, that's really all they care about. I've not yet met a member in my 15 years as a superintendent who really cares what practices you're doing to get to those conditions. They care what it is. When they go out and play, is it good? If it was good today, is it going to be good tomorrow? Or is it going to be good the next time I play? Or, I come out and play I played last Friday. Golf course was great. Perfect in my mind. Now I play next Wednesday. Is it going to be the same as it was last Friday? Or is it some diminished version of what I played on Friday because they did some maintenance on Monday that has now reduced the quality of the surface to some amount, and now we had to build it back up? And that was one thing I did hear from our members. It was in a green committee meeting, and they were saying, I just feel like the course is sort of inconsistent. And I said, okay, we'll focus in on that, because I need more information so that I can do a better job of changing that. What's inconsistent? Well, the greens. Okay, well, what is it about the greens? It's the sand. Okay, so then we talked about it, and that was during a time when I was regularly top dressing every 2 weeks. And we would top dress oftentimes on a Sunday evening. Then we wouldn't mow on a Monday. Maybe we wouldn't mow on a Tuesday. Mow and roll on Wednesday. And okay, so for that weekend, the quality of the greens start to come back. And then by the second weekend, the quality is great. So let's say somebody plays on that second weekend, Friday, Saturday, and the greens are awesome. Then they play the next Wednesday. They bring a guest out, and they tell their guest, wow, gosh, I played this weekend, and the greens were spectacular. Now, since they last played, we've top dressed, we've skipped a couple days of mowing, maybe skipped a day of rolling, and they come out with guests on a Wednesday, and it's just not the same. And maybe they play early in the morning, and their ball is accumulating because there's moisture on the greens and there's sand, a little bit of sand on the ball. And I totally understand this. Look, a lot of superintendents might say, well, hey, that's what we need to do to have the course be great tomorrow. But I can relate to a person who is a member at a club and wants to have these great conditions every single day. That if that was me and I wasn't growing the grass and I was just playing the golf, I can see where that would be irritating. So that is sort of one of the things that got me to thinking, how can we have more days of great conditions and not ride this sort of roller coaster of conditions, which largely, in my mind, were coming because of top dressing. So Carl, I don't know that I'm answering your question, but no member that at this club is going to say, well, shouldn't you be top dressing more? Shouldn't you be top dressing every other week? They don't care about that. What they care is that the conditions are good every day that they play, and of course they want the conditions to be good or better the next year. So that, I think, is why all of this testing and data accumulation has become so important to what we do here. Is because that is telling me, are we meeting the goals that they have? Are we losing ground in any way? I just recorded a seminar for virtual GIS this year. And I said, this is no different than a person who records their weight every morning or records their blood pressure on a regular basis, looking out for potential hiccups. If you don't record your weight every morning, let's say, and you have a week of holiday eating and you feel like nothing has changed, but you have gained 10 pounds, and then sort of in your mind, that 10 pounds that's the new normal and you're not paying attention to it. And then let's say the next Thanksgiving and then Christmas, and maybe Christmas week, you gain another 10 pounds. I'm sorry, I'm not trying to I'm just giving an example here that isn't golf course related. Now all of a sudden you're 20 pounds from where you think you should be, and you're not aware of that because the changes sort of happened slowly and you haven't noticed it. And then all of a sudden you're like, well, geez, something's not right here. And you step on a scale and you're like, wow. So if you're looking at these numbers every day or at whatever interval makes sense, Om246, it only makes sense to me and to Micah to do it once a year. But green speed every day, smoothness every day, firmness once a week, whatever that amount of time is, it's telling you if something's going wrong, if something's happening that is unintended, based on what your goals are. So yeah, I don't know if that answers your question or not, Carl. I think that some of the feedback I get on this from colleagues is this thing of concern. It's easy to continue doing what we've always done when we know that we're getting the results we want. But I think, and this has been something Mike and I have talked about a lot over the years, and even I teach the bentgrass course with Doug Soldat in GIS. I've heard Doug talk about it. Doug just did a great podcast with Joe Galati, in which they talked about this subject. I think we're doing too much. I think we're doing, this Monday maintenance thing has become this big thing, and I get it. Like members need to know that the course needs to be maintained. There's no doubt about that. I'm not saying that we shouldn't be telling our members we're not doing, but you should know if you're going to do something to your golf course, you should know that you absolutely need to be doing it. And that's what all of this is about for me, is knowing, yes, I need to be applying this amount of sand. Yes, I need to be doing this amount of rolling, this amount of mowing. Yes, I need to be applying this amount of potassium or not applying this amount of potassium. Somebody on Twitter just retweeted I think Micah did it, and then there was some commentary on it. A picture of two of our guys, let's say 8 years ago or so, applying granular potassium after a rain event. And I sort of chuckled with him, and we went back and forth a little bit about my response to his question. What are you replacing? And I said, something potassium that's washed away with the rain. And I just didn't know. I had some consultant that I worked with had told me that was the thing to do, and I wasn't knowledgeable enough in that area to realize that maybe we don't or we shouldn't, and I hadn't learned enough about it. And so we were doing it, and it was a wasteful process. Yes, a few bags of potassium fertilizer don't cost that much, but it was 2 guys to apply it, and we had to figure out the timing, and then you put this granular on the surface that could affect play for a day or two, and we just didn't need to be doing it, and we're not. And soil nutrient analysis tells us that we're not having any sort of issues because of it. So hopefully, Carl, that speaks to that idea. But yeah, and again, we're not doing nothing. We'll talk. We can, we still are applying top dressing. If someone were to walk on our greens right now, they would think, they'd say, "Oh yeah, this is not nothing as far as sand." I mean, they are quite heavy right now, but that's half the sand that we're going to apply for the course of the 12-month cycle. So
Awesome.
there's another question from TJ that I think gets to this point a little bit too, Micah.
Yeah, let's answer all the questions
Okay.
right now. This is awesome. This is exactly what I wanted the office hours to be, is something where we can talk about a technical subject a little bit, but also to have these kind of excellent questions. So I'll show TJ's question. He's asking about layering, which is an excellent question.
Yep, I'm glad he asked that, because my old way of thinking before we did this would have found that to be concerning too, and that would have been the reason I'd say, okay, I want to put these out on a regular basis to reduce layering. Visibly, I don't see any issues with layering. I haven't seen that with this. I guess maybe if I'm really being critical, I could look at it and be like, okay, here's the pre-winter sand. Here's the May sand. Maybe, but again, let's go back to the data. I'm working to grow the least amount of grass possible. So that gets into clipping volume and rates of PGRs and that sort of thing. Amount of nitrogen and paying attention to growth potential, and not applying nitrogen based on growth potential. And that it is my belief that controls the growth to a point that we don't we're not worrying about a layer. So, I mean, that's a simple way of saying it. But again, it's combining data with visual observations and saying, I don't think there's a layering problem here. And Micah, can you comment on layering a little bit, or some of your thoughts on layering, and how you feel about it? Because we have had that discussion just a bit.
I have seen more layering issues where the turf is great than I've seen bad turf that's caused by layering issues. So it's obviously, layers are something that people should rightly be concerned about, but it doesn't necessarily mean that it would be an issue. And anybody, I'm not going to bring up your tweet right now where you shared the pictures of those cores when you collected the samples on October 11th, I think, but those were beautiful. And, there's roots, there's consistent coloring through there. There's, it looks nice. And it doesn't look like layering. So I would encourage people just to monitor it, but don't be afraid of imaginary things that may not have caused a problem yet.
Micah, do you want me to just,
yeah, can you?
I can share.
I'm going to answer. Here. You bring that up on your screen. I'm going to answer Eric's question from a long time ago. Eric asked value in spring and fall testing for courses that are open year round, and when they're doing cultural practices year round. Even in a tropical environment, I think only the really high-end courses would get a value in measuring twice a year. I think doing this once a year, this type of testing is sufficient, because otherwise I think you might start chasing numbers, and I want to give some time for things to stabilize, for the sand that you've applied to have whatever effect it has, for the organic matter accumulation rate to happen, for organic matter to develop, for organic matter to mineralize. That's what I'm looking for. So I like doing this once a year. If people want to do it more often, that's fine, but I don't know that it's absolutely necessary, especially if your surfaces are performing well, because then you just you can calculate. Once you start doing this as a time series, you can calculate what you need to do for the next year, whether you have a year-round growing season and you're doing maintenance year-round, or whether you have a shorter season. So my answer is I don't really see a huge value in it, but for high-end courses that really want to know what what the results of your work in the last 3 or 4 months have been, then you can check that if you want to. I think as people do this more, they will come to agree with me that doing it annually is sufficient. All right, Chris, did you?
I have it ready to go.
Oh,
It's
sweet. That's beautiful. How do I? Oh, look at that. Very minimal layering, I would say.
Yep. Yep. So just to answer TJ's question, that's a plug that last saw sand, and that was about the beginning, let's say October 10th, I took this. And then, the last sand prior to that was August 3rd. And now it has a lot more sand on it. But, nowhere in there could, maybe if someone's being super critical, they could say, well, that might be, but I just don't think you see, I don't think there's a layering, and certainly nothing that's concerning. Another thing that I think I've come to maybe think, and this is totally anecdotal, but something I think that happens is if you are constantly building sand up on the surface, I think that I see a lot of, we're top dressing to improve the firmness of the greens. And I think that probably is true to some extent, but I also think that in order to really do that, that sand needs to have some amount of organic matter or plant material growing in and amongst it. So if you just have a layer of sand sitting up here on the top that is, being constantly built throughout the season, I wonder if that surface isn't going to be a little bit softer than if you put down a bunch of sand and then the plants all grow up and through it, and the roots and the everything, all that plant material become part of, there's this matrix of organic material and sand. And I think my feeling is that's firmer than if it's just, fresh sand always being on top of the surface. Again, that's completely anecdotal, but that's something I've sort of noticed as we've gone through these 2 years of no real in-season top dressing. Is I think the greens are firmer because of that.
Very good, Chris. Thank you. Let's see. We still have a couple more questions. YouTuber 49 asks about the whether the USGA profile will be replaced by something better, or if it's still a good construction method. I'm going to also recommend Doug Soldat's podcast with the Talking Greenkeeper with Joe Galati. And they talked about that. They talked about the new greens at Marion, some innovative construction methods. The USGA method, those recommendations are a standard. It doesn't mean it's the best way, but everybody knows that it can work.
I mean, my experience has been, in now 9 years of managing these USGA greens that were pretty new when I got here, and I think still perform at a extremely high level. I think if you are on top of everything you need to be on top of, they're quite good. But there's been lots of talk. Dan Donnelly has talked about this, the idea that once you start top dressing a USGA green, you're sort of leaving the root zone behind. I think we can see that a little bit, Micah, in the testing, the various 0 to 2, 2 to 4, and 4 to 6. That 4 to 6 is just sort of it's everything's moving down. What next year when we test, part of what was 0 to 2 this year will be 2 to 4 next year. So there's obviously going to be this movement down. But I think if you're staying on top of everything you need to do, a USGA green is quite good and performs the way a person would want it. But it does seem to me that I keep looking at the picture of the core here. That's why my head is going to that direction. But it seems to me that if a person would but if a system, the USGA system, and it is a system, is not being maintained properly or isn't having the right kind of things done to it. Let's say a course, let's just say a course builds USGA greens and then they have some sort of issue with, they don't have the funds then to do the things that need to be done to maintain them properly, whatever those things might be. I think they will get to be pretty bad quite quickly. An organic matter would build up quite quickly on the top if a situation with a lot of over fertilizing, let's say, over watering, and if you get a really heavy layer of organic matter on the top of a USGA green, that system is not going to perform very well. So I think it can be quite good, but can get into trouble quickly too if it's not managed properly. So it's whether it's the best system or not. I don't have that answer, but here's something I've always thought is interesting. If you were to let a course go fallow for a year, I think, Micah, you've maybe written about this or shown pictures of courses. You go find a course that doesn't exist anymore and has gone away. All the native soil areas are probably, after a year or more, are going to be generally okay. That turf is going to be alive. You could maybe, let's say, 1 year of not maintaining that course, go back and start to mow the fairways and, get a reasonably good product after, with some work. But the greens, like a USGA green, especially if it's a USGA green, they're probably going to be dead, because there's just no sustainability there. Like, that needs the hand of a turf manager constantly, all the time, to survive and to be the type of surface that they need to be. So in that regard, I don't think they're very self-sustaining, but that doesn't mean they don't produce great turf. So that's I guess my way of sitting on the fence on it a little bit, maybe.
Yeah, I think that's really the only way to be about that, because there are a lot of different ways to build greens, and you're right. Again, there's always stuff on my website. I'll recommend that again. I think if you search my website, you can probably find some pictures of some abandoned golf courses where the putting green is dead. Look for ecology. If you search for turfgrass ecology, I'm not sure if those are on my current site, but they might be. I think there's over 500, maybe close to, I think there's more than 500 posts that are searchable on the new site now. Or not new, it was new a year ago, current. Awesome. We still have more questions. This is unbelievable. Eric's asking again about, in the Pacific Northwest, annual bluegrass that can grow November to March in the off season. If it's something that someone is interested in and really wants to know the number and how it changes season by season, I think that could be, then you can certainly test and measure it. I always want to simplify. People might think that I like to make things complicated by all this data, but I'm really trying to make things as simple as possible, which maybe I don't always convey that. But for me, sampling once a year, now we combine what happens in the winter when it's growing, we combine what happened during the summer when it's growing, and we just look at it every October, for example. For me, that answers all the questions. I don't feel like I need to know what it is in June and again what it is in October. But I think, yeah, I mean, Eric's from a tournament venue, major championship venue. I think for that kind of facility, maybe you do spend a few $100s and do the testing twice a year, and then you really know. But I'm often thinking more for the average facility. I don't know that it's necessary to measure twice a year. And John's asked about native soils, fairways, and tees. That is a great question, whether the OM246 testing is applicable to these. I know, Chris, you did fairways and approaches this year.
Yep.
Um,
Yep.
yes, it's applicable. I think the most value um, is on putting greens because those are the most intensively maintained surfaces. But if you're concerned about ball bounce and if you're doing things to manage organic matter on, I think tees and approaches, fairways, yeah, it just depends. If you want good surfaces that people are going to stand on when they're teeing off, and especially if it's like a tournament type of venue, then it would make sense to me to measure this.
I think, and we talked about that. In fact, in our report this year, you basically said, I'm not going to give any recommendations. I'm not even going to do any charts because it's 1 year of information. I don't have enough background data on this to give you any kind of recommendation. But here's the data. Now, next year we'll have 2 years and we can start to put it into a time series. So it's,
and
yeah.
that's something I think you told me. Well, you've questioned sometimes whether you can just pull up the cores on fairways, right? And then
Yep.
spread the
Right.
sand over the top. And you want to, that's a big operation.
It is.
And that's a lot of sand if you're putting fresh sand or if you're just recycling the sand. And it does make sense in that case, I think, to measure this a little bit.
And that's part of the reason I want to do it. We're sort of making this transition where I think that our routine's we've top dressed fairways out here for many, many years. There's enough sand built up in the profile of the fairways to pull a plug that is basically completely sandy root zone. And then, so I want to know, okay, we're at the beginning of that now. If we do that for a couple of years, how is that impacting the organic matter in the fairways? So that's kind of why we started doing it. So
Awesome. How's your time, Chris?
I would say it's interesting. Anytime I've collected any of this data and I've started doing it and I've gotten over that hurdle of starting, every time I've done it, I always have thought to myself, I wish I had this from previous years. It's, it always makes me realize that I can't believe I wasn't doing this before. So.
Yeah. How's your time? Do you want to keep going and shoot through the rest of the report?
I can go for as long as people would want to listen. This is a great subject, and we're at a nice time of year here in Minnesota where my time is, I don't want to say limitless, but I'm not under any sort of time strain.
Cool. Good. Well, let me flip back to the, to the chart then.
It might be good, Mike, if we just talked a little bit about how we've come up with the prescribed sand, and that might be where you're going, the amount of sand for a year.
That would be very good. Let's look at the report to show what we're trying to achieve, and then I'll show how I calculate that. So I think I can share that screen. There we go. So we've got those numbers that compares to species, and then so basically everything's fine, and the idea is kind of like we want to keep things the kind of where they are. And then the next chart I show is like a scatter plot that identifies the different greens. So now the fifth green is, I think it's the worst one out there in terms of the way the grass doesn't seem very vigorous. And I've only been there.
It's our most difficult green to manage. That's how I would describe it.
And it's got the lowest organic matter at the surface.
Yep.
And then
Yep.
9 green is in full sun, and it's got the most organic matter.
So 9 green is perfect. So if I would label those 2 greens, I would say that when I go out to look at greens in, let's say the weather is, you're in the middle of the summer and the heat index is 105, and I want to go look at a green to see if there's anything that's, becoming an issue, number 5 is where I would go. That is our low end indicator green. And number 9 would be a green that I would never hardly think about in that regard.
Excellent. And this is very typical where when people do this type of testing, the healthiest greens, the best performing greens tend to have more organic matter, which is, and the worst greens tend to have the least because they just don't grow as much. And or they don't produce as much organic material underground. And I think that can be a caution against trying to go too low. So here we've got the numbers, and then now I'm not showing the background by only bent grass. I'm showing everything. So for this test on putting greens, the organic matter goes up sometimes as high as about 20%. And then also this shows why we don't do so much testing down at the deeper depth. You see there's just very little variability. Just go down to 2 to 4 centimeter depth. That's 0.8 to 1.6 inches. We're basically from 3/4 of an inch down to 1.5 inches below the surface. It's nothing. I've got a handy sampler here as a prop, and these lines on here are 2 centimeters apart. So if this would be the 0 to 2 centimeter depth, that next depth, it's nothing. It's a tiny bit below the surface. So as we go down to those depths, there's very little variability, and you go down to the 4 to 6 centimeter depth, they're quite close. So we're not worried about that so much, but we do want to make sure that at the surface it's staying relatively consistent. So then let me bring up a different screen, and I'll show how we calculate this. So it turns out that there's a surprising amount of complexity. There's a surprising amount of complexity in this, in terms of math. So I'm going to go to the Shiny apps, and I've got a calculator for this. The Om246 calculator. So what this does is calculates the organic matter accumulation rate. I think not everybody knows about this or thinks about this completely. Do they, Chris? I mean, when you first start doing this, you're probably thinking about what the organic matter is, what the total organic, what the number's going to be when you do the test. But, and then everybody wants to know, how much sand should I apply? Well, I can tell you, if you apply this much sand last week, what your organic matter will be right now. But after the grass grows in April, May, June, and July, you have some organic matter accumulation. And that is difficult to know, but we can figure it out by doing this organic matter testing over time. And that's what this calculator does. So oops, it's showing the wrong, I'm gonna try again to share my screen. It's not sharing the one I thought I was. Shiny apps. It must have opened in a different window. Oh, wait a second. Sorry. I'm
This is the
just
beauty of live recording.
yeah, then this is totally my first time doing this too, but this should be the app. I can't believe the internet has worked all through this time. All right, so
Quite good. Yeah.
here's a shiny app that has the calculator. So I'll jump to the OM accumulation rate part. So it's just showing some default stuff, but let's change some things. So I'm going to change we're just concerned about the top 2 centimeters. So I'm going to change that to 2. You were 4.9, weren't you, Chris?
Yep. Yep.
So you were 4.9 last year and you were 4.9 this year. So this is now going to calculate the organic matter accumulation rate, which is really important because we need to know how rapidly it's accumulating before we can figure out how much sand to apply.
Mm-hmm.
Then the date range was 1 year. I'm not going to change it. It was October to October. This is still 12 months.
Yep.
And what did you apply? 5.2 or something?
I was just above 5, like 5.3 or something like that. Yeah.
But this is where it gets tricky because a lot of that went in with the dry-ject.
Yep.
And so I guess that right at the surface, the amount that stayed at the surface might be 3.
I think that's that's what I recall you saying.
So I think that's what I did. So I'll change that to 3. And now it says that your organic matter accumulation rate was 9.1 grams per kilogram of soil per year, which is interesting to know, but and there's a surprising amount of math behind it. But now we just calculated that. You can't do anything with that except when we plug that math in also to the next tab here, the sand requirement. So now it's remembering that we're working with the 2 centimeter soil layer. You can change this if you want to, but it's remembering that we were at 2. We're currently at 4.9. We'd like to stay at about 4.9, and it brings in what our accumulation rate was, which is 9.1 grams per kilogram. And we want to be a year from now, we'd like to be the same. So it's saying that you need to put 2.6 millimeters of sand into the top 2 centimeters over the next year, given that the accumulation rate we've calculated from last year is the same accumulation rate that you would have next year. That's how that works. So I probably put something similar to that in the report, but anybody can do this with the calculator that you can also find on the Asian Turfgrass website.
There's some great, I don't know if you saw them, Micah, as you were doing that, but Jason and Eric and Andrew had some great commentary. Andrew's probably staying up quite late for this, which is cool.
That's past your bedtime, Andrew.
Yeah.
Wow.
Had some commentary about aerating, in that, and if we're going to poke holes and put sand in there, does it make sense to just do it, keep it in the 2 centimeter depth? To me, it seems like it does, because as I look at what you just came up with there, Micah, if we're going to apply 5 millimeters of sand, because we had talked about 5 millimeters being an amount, but then I think you also split that into 3 millimeters in the top 2 centimeters, and 2 millimeters would just, assuming he's going to go below that from some sort of aerification holes. Okay, well, let's just, as maybe like a thought exercise, if because I just applied leading into winter 2.5 millimeters of sand to the surface in 2 lifts, let's say two applications, 1 application each of 1.25 millimeters. So in theory, if that's all we did for the year between now and the next time that we do our testing in October, in theory, that should keep us level without having to worry about any sand going into the profile. It would be interesting to see if that's the case. Now, that doesn't account for the idea that at some point we might want to make some holes and put some sand in there. I'm not saying we we, I don't know if we do need to do that. At some point, I'd like to find out, but I know
Yeah.
that's something Andrew's stayed away from.
It's interesting. I mean, like, some of these things are pretty crude calculations, but we can certainly test it and see how it works. It's like now I start thinking about layering and stuff like that I just said is it's not a problem.
Right.
But then it's like, yeah, if you top dress once a year, as you do this and see how the surfaces perform and get the data to confirm that things are not going completely haywire, you can start getting ideas of things that you never thought were possible.
Yeah.
Suddenly you start to wonder whether it might be possible. Like
Yeah.
Andrew this year was only able to get one top dressing down, and one top dressing in the year, and the greens performed great. So those kind of things that I never would have thought that was possible, I would have recommended to apply 6 or 8 times that much sand. And now all of a sudden I start to think, yeah, maybe you can do it with once a year. Maybe you can do it with very little.
Well, and so, if I think about that bobble test chart, let's say in theory that we decided, okay, the 2.5 millimeters of sand that we just put down heading into winter is we're going to go with that. We're going to roll with that amount because we think that will keep our OM in the top 2 centimeters where it needs to be over the course of the year, and then just roll with that as our practices for the year. Maybe we needle tine if we feel like we need to open up a hole on the surface. So maybe there's something like that happens, but there's no big aerification event. And then I look at that bobble test and I go, okay, we come out of winter and we quickly get to 8, and then we quickly get to 9, and then we just stay at 9 until the end of the year. In theory, who is going to complain about that? I'm not. I hate aerifying. I hate it. I don't get excited about that process at all. But again, the testing would tell you, is there undue harm being done? Because I know that would be the concern. Other colleagues of mine would think about something like that and hear that and just think, oh, they just shudder thinking, I can't not do an aerification. I think there's also some concern that if you don't do it this year, then is that going to become the expectation in years, in coming years, and then you lose that opportunity to do it. That needs to be considered.
Yeah, I've heard that one.
Yep.
That's not my favorite argument, because I'm just like, man, who's going to complain about skipping something when you might have to do it in the future? But
Yep.
if we make the greens better this year by not aerifying, why is that a bad thing? Like,
right.
Why, but yeah, that's an argument I've heard too. So I want to show one more thing on the chart, and then maybe we can have an open discussion, and then wind this up. I'm gonna figure out this screen share thing again. That was not right. This one's gonna be right though. So I'm gonna share the report and show something else that has slightly less complicated math, but that is brilliant, I think. So a lot of people are familiar with the research that Dr. Caro did in the 90s and early 2000s. So some USGA funded research looking at organic matter in the surface layer of bent grass greens. He also looked a little bit at ultra dwarf Bermuda grass greens, but see, he did that on not at a 0 to 2 centimeter depth, not at a 0 to 1 inch depth. He did it at a 0 to 2 inch depth. And so now we're talking about something that's from 0 down to 2.4, 0 to 5.4 centimeters below the surface. And is that right? Something like that. It's getting very late for me too. I think something like that. So anyway, we can make that calculation because we're measuring at 0 to 2, we're measuring at 2 to 4, we're measuring at 4 to 6. So we've gone all the way down below 0 to 2 inches. So we've got that entire layer. We can estimate what the little difference will be. There's a slight overlap when we go from the 2 to 4 into 4 to 6. So we use some math to calculate that, and we can estimate. Well, I mean, basically we've measured it, and then we just do a calculation to figure out what the 0 to 2 inch is. And so Dr. Carroll said if you're over 4%, that is an indication that you might have a problem, especially on bent grass greens in the American Southeast in the summer. And bent grass greens they're difficult to manage in that type of climate, and they can fail pretty bad when it gets hot, when there's not enough oxygen in the root zone, when there's too much water in the root zone, not enough pore space, you get big problems. So he put the number 4% out there as an upper limit that might be safe. And so I show that last because I think people would be interested in this also. So I make that calculation. I just started doing this on the reports this year. And you can see for Hazeltine, so now we're looking at the effects of your dry jects, the effects of when you're putting the solid tine and filling those holes with sand. We're looking at what's happening at the surface. We're looking at the entire effect through this depth. And this is going from 2.5, 2.5, 2.9, 2.9. So it's staying flat all through that depth. I'm sorry, this particular chart is showing from 0 to 6 centimeter depth. I make the calculation from 0 to 2 inches in the footnote. And so where you're at in October of 2011, you were at 3.3% if that's expressed on a 2-inch basis. But the chart, I'm showing everything down to 6 centimeters. So I think this is kind of cool because now you're looking at what's happening with the sand that you're putting down below the surface too. And to see that just staying flat with basically you're only disrupting the greens a few times a year, it's a nice reassurance, I think, that what you're doing is not causing organic matter to accumulate too much.
Yep. I will say too, and we've seen if people are recalling the charts from before, you can see from the first 2 times we tested to the third time we tested, there's a jump there. And I will say that after in 2017 and 2018, I kept the greens very lean, and this was sort of before. That was when I started clip volume, and I would say that this could be another 2-hour discussion, but we've talked a little bit, Micah, you and I, before about what are measurements a target or are they to inform decisions? And I think when I started doing that clipping volume, I was focusing a little bit more on it being a target. And so in 2017 and 2018, the first 2 years I was doing that, I was sort of focused on like keeping that clipping volume number low and really low. And I think in that regard, I think we had some surfaces that weren't ideal because they were too lean, and we weren't growing enough grass for in simplistic terms. And so those organic matter numbers are a little bit lower at the beginning of that, and then they come up a little bit as we just grew a little bit more grass. But that's one thing I'm really happy about. Comparing this year's results to last year's results is growing more grass, applying the sand that we did on a sort of prescribed in a prescribed manner, and getting that number to stay where we want it to stay is something that's really encouraging.
That's very good. I think this is an exciting time in turfgrass management because we keep finding ways to produce great surfaces with less work. I think it's pretty cool. I was emailing back and forth with Bjarni today. He also collected samples, I think, on October 11th. So I've sent him a Om246 report some weeks ago, and he and I have both been a little bit busy, so we didn't really chat about it until today. And I asked him how much sand he put. He put 3.2 millimeters of sand, and his clipping volume this year was about three 3 liters per square meter, or
Okay.
3,000 cubic centimeters per 3,000 cubic centimeters per square meter, or what would that be? I stopped thinking about it in terms of 100 square meters, but maybe.
But
But
I wouldn't be able to do that. I'm looking at my charts to see if I can get that number from out of my data somewhere.
but it turns out to be something that matches exactly with the research that was done at Rutgers. When they did all that research about anthracnose, they did not measure clipping volume, but they reported what their nitrogen rates were, and they reported exactly how much sand was applied. And we know what the climate is like at those research plots. We know what the temperatures are like. So based on that, I can predict approximately how much clipping volume they probably got from the amount of nitrogen that they applied, because you'd expect a certain maximum growth rate. The grass can't grow any more than that. So we expect a maximum growth rate for the amount of nitrogen applied. We know exactly how much sand was applied, and we know what the temperatures were. So based on that, I guessed that for every 1 milliliter, cubic centimeter of clippings that you harvest per square meter, it might make sense to apply 1 cubic centimeter of sand. And it turns out that's basically exactly what Bjarne's done. And his organic matter there in Iceland is right in the range that STRI recommends, that the RNA recommend, that they're shooting for their open championship venues, right in between 4% and 6% in the top 2 centimeters. I don't generally recommend specific ranges for anyone, or for everyone. I don't recommend for everyone to be like that, because I think it should be done on a course by course basis. But certainly it's quite comforting to know that he's applying a relatively minimal amount of sand, that it matches the approximate growth rate he's getting. And he also happens to have a OM2 value that's right, like at an open championship type of level. All right, Chris, we lost your camera. Are you, maybe he's got a phone call. Okay. I'm going to check the chat real quick. This is great to have so many people contributing the information. I agree with everyone about just punching holes really, really shallow and just filling those with sand. Based on these numbers, we just don't see so much happening down at the 2 to 4 centimeter depth, or the 4 to 6 centimeter depth. So it seems like we could do quite well with just getting a lot of sand right into the surface. And okay. All right. Well, everyone, I don't see Chris. Maybe he had to take a phone call. I'll stay on here a couple more minutes in case anybody has any more questions. Okay. Chris sent me a message. He had to leave the office. He said he's going to be right back. There he is. Hey.
Yep, I'm back.
I stayed on. I answered it. I made a few comments.
One of the disadvantages of me doing this in the morning is that I've had about 16 ounces of bulletproof coffee, and which doesn't allow me to go for a 2-hour period without using the restroom. So
okay, well, good.
Back.
Welcome back.
Micah, you've had my coffee, right? We had some in 2019.
I was very glad to have it. Thank you.
Yep.
It's delicious. Do you still do the coconut, or are you doing butter? What are you putting in there?
So butter, about 2 tablespoons. This is about 16 ounces. About 2 tablespoons of butter, 2 tablespoons of MCT oil, and then a scoop of collagen powder. And then I blend it with a immersion blender. And it's as you can attest, it's quite good. And then that'll be kind of my sustenance for most of the morning and early afternoon. So
That's excellent.
I think Phil Mickelson has become that's kind of his mixture as well, if I'm not mistaken. So
Yeah, coffee is delicious. I drink a lot of it. We were just up in northern Thailand, where at the higher elevations around Chiang Rai, kind of the Golden Triangle area where there used to be a lot of opium poppy production, and now there's tea and Arabica coffee and various other types of agriculture there. But just some splendid coffees, really flavorful Arabica that you can get, and just coffee shop after coffee shop in these towns. So that was enjoyable.
Yeah. Did you talk some of these discussion that Jason and Steve and and Eric were having about?
Yeah, I agree that it makes sense to me to just punch a lot of holes at the very shallow depth and fill them with sand, because there's just not much happening down below. So if you don't have a compaction problem, if you don't have other reasons why you need to decompact or make holes down deeper, if we just consider this only from a organic matter perspective, then it doesn't make sense to do anything below 2 centimeters.
Mm-hmm. Yep, I agree. That's kind of what we're thinking about. Now I'm really intrigued though. I'm wondering if our 2.5 millimeters just on the surface is enough, but we'll see. We'll see.
Yeah, I think if you keep the growth rate under control, it probably is pretty close. I think it's like chasing your tail to keep trying. Like I used to recommend people put 12 to 15 millimeters of sand, right? That's 40 to 50 cubic feet. Maybe not in your climate, but in warmer climates, I'd recommend 12 to 15 millimeters, which is 40 to 50 cubic feet per 1,000 square feet per year. And now we're talking about numbers. Last year you put 5 something. I said Bjarne put 3.2. Andrew put 1, I think, this year. So now we're talking single digits, and pretty much everybody's less than 5. So these numbers are such a departure from the way that I used to recommend. It's striking. And I never would have thought this is possible, but now people do this, get good results, and then you start thinking, maybe by putting such a small amount of sand, we don't have to grow the grass so fast. So then we don't need such an organic matter accumulation rate. Because I think sometimes people are doing so much work that they're maintaining the grass at a growth rate, which produces an organic matter accumulation rate, but they're maintaining it at a growth rate that seems normal.
Right.
But that normal is based on they're punching holes and spreading sand that the grass needs to recover from. Or verticutting, right? Some people like to rip the grass up and verticut a lot. And that requires the grass to grow. But if you're not doing those things, you're able to grow the grass at a slower rate. It may be that allows for a lower organic matter accumulation rate. So this all just kind of works. Maybe.
It's a little bit it's like a self-fulfilling thing almost, in that you do all this work and then it requires are you doing all this work because you're growing so much grass, or are you growing so much grass because you're doing all this work? And my experience has come to be that we're growing all that grass because we're doing all that work, and the work can be reduced allowing the grass growth to be reduced as well, keeping the quality and the quality doesn't drop. I think, again, we've talked about this again, but I think that this is the crux of the matter. And Carl asked this question. People are fearful of stopping doing the work because they think that means that their surface quality will deteriorate. But I don't think they realize that if they stop doing all the work, all of the other things that they'll also be able to stop doing, all of the other things, but maybe not, but the other things that they will stop being able to do, the amount of fertilizer they'll be able to reduce, fertilizer nitrogen inputs they'll be able to reduce, and the improvement in quality that comes from that. I think, again, there's multiple ways to get to a good surface quality. Absolutely. I'm not saying this is the best way to do it, but what I know from listening to our golfers is that they just want to play golf. When we open the golf course on April 15th, they want to just play without being disrupted from April 15th until November, whatever, 5th, 4th, October 31st. They just want to play undisrupted. We have roughly 170 days of golf that will be open. And of those 170 days, let's say 30 of them you toss out because the weather's crummy and people wouldn't play, or it's too cold, or it's a thunderstorm that results in a rainout on a particular day. So now we're down to about 140 days. Now, how many of those days can we perfect the quality of the surface for our golfers? That's what I'm looking at. Can we do 140? Maybe not, but I think we can get pretty close to that. And that's the goal of all this for me.
Yeah, I saw Kaya Keeper mention that if you don't have maintenance Mondays, and I think in Japan, golf courses are usually open all week, so there's no maintenance Monday, and then you have a couple tournaments. He happens to have a warm season grass on the greens with one pro tournament in June, another one in August. So it's like you don't have Mondays to do the work. And you can't really do the work because during the growing season you have tournaments, and it kind of fixes itself. So that's a joke, but it's funny that it did kind of fix itself there, and we found out that it works there. So that's pretty cool.
And I might say that a pandemic and just sort of wanting to not, I don't know, it kind of, that whole last year just kind of froze me, and I just, it was weird, but I didn't want to do anything. It's not that I didn't do anything, but it just my mind was so focused on the fact that it reduce risk in every possible way. And I look back on it now and I think, how could the idea of top dressing greens reduce risk of COVID? It couldn't. But at that time, nobody knew exactly what the real risks of almost anything we were doing were. And again, it's not that top dressing greens was particularly risky, but we were just trying to do everything so simple. We had fewer staff. We had people riding around on a cart by themselves, trying to stay as far away from other people as they could. And it just sort of led to this mentality of, doing less. And one of the things we did less was top dress greens. And by accident, we almost found out, wow, look at what the quality of these surfaces were when there wasn't sand right there, that the rollers and mowers were just smashing the grass, the leaf blades into all season long. So
I think something that I have noticed, I wrote an article about this for my column in Golf Course Management magazine, was what I've learned from tournaments. And something that we can learn from tournaments is they don't do deep and infrequent irrigation during the week of a tournament. They don't spread granular fertilizer during the week of a tournament. They try to minimize clip volume during the week of a tournament. They definitely do light and frequent irrigation if necessary during the week of a tournament. They don't, did I say they don't aerify? They have no need to vent the greens.
Right.
The grass doesn't need spa day during the week of a tournament. And They don't spread sand unless it's an emergency during the week of a tournament. So there's a lot of things that that I've learned from watching how tournament play is, and then saying, wait, if we're trying to produce tournament conditions all the time, or like you're saying, trying to hit this really high standard of playing surface for the season of the year when the golfers can play. You said 140 days or something is maybe the target. Well, then you want to be doing things like not top dressing, not venting, all the things that you do during a tournament, minimizing clipping volume. So to do that, you don't put so much fertilizer and so on. So it's an interesting way to think, because I used to swear by deep and infrequent irrigation to the point that I caused problems with turf. This is back when I was a golf course superintendent. Andrew knows, or Kaya Keeper, as he styles himself here on the internet to be somewhat anonymous, but I think I just dropped his name. Sorry about that, Kaya Keeper. But we kept it so dry when he was working with me at Habu Country Club. That was USGA greens, pen cross, creeping bent grass. We didn't really use wetting agent. We'd let it get so dry, then we couldn't re-wet it. And it was all because I was trying to do deep and infrequent. And we would have had, and also Jason Haynes, I think, discovered that the grass is just better when you irrigate it and maintain the...
I have found the same thing.
Yeah.
I had the same idea about watering fairways when I got here, when I came from Northland to here, and I've totally changed 180 degrees. When the fairways are dry and need water, now I will water the areas that are dry and need water every night. That's not the entire fairway program, but it's the areas that need it, and they get that water every night, as opposed to keeping them, and it's small amounts, like 6 to 8 minutes of runtime a night. So, but our surfaces are better quality visually, just a better overall turf, but just as, if not firmer than they were when I was trying to do this deep and infrequent. And I've seen you talked, I remember you talked about that here in Minneapolis, Micah, about that. And you had a chart that showed actually how much less the moisture content can be when you do, frequent irrigation over time, as opposed to, a lot and then let it sit. But yeah.
Doug Soldat taught me that. He was visiting Thailand in 2009 for the conference, and it was interesting that he told me, just like offhand, he's like, you can use less water if you irrigate light and frequent. And I was like, no, that can't be right. I know it. It was all the way until 2009. I kept thinking that you'd use less water and everything would be better, ideally, if you do deep and infrequent. And he just kind of offhandedly mentioned this. And then I worked through the calculations, and it's like, oh my God, yeah, if you apply a little bit of water every day, you theoretically can keep, you can apply less water and keep the soil drier and do it safely. If you average everything out over time.
There's a question from YouTuber 49 about volume of play, and I don't know if he's asking the question of his fellow commenters or if he's asking the question of us. But Hazeltine is a course that gets quite a bit of play, close to 25,000 rounds over those, let's say 140 to 170 days that were open. So that's quite a bit of play. And I've noticed that with sand not being constantly present on the surface of greens, our resilience to traffic is much better. And that goes for both golfer traffic and roller traffic, especially. I have, in my first few years here, we would see that we deteriorated the edges of greens with the rollers quite a bit. And in the last 2 years, without top dressing in season, or minimal top dressing in season, we have not seen that reduction in quality from the rollers. They can go out every single day and roll to the edges without any trouble and don't diminish that quality at all. So that's one type of traffic. And then golfer traffic, is also quite substantial here, especially on some greens. We talked about the fifth green earlier, and that fifth green has a way that it's a shape to it and a nature to it that forces a lot of traffic into a very small area. And so we see some traffic impact as we go through the season, but it's less. And in fact, prior to these last 2 years, I was oftentimes applying supplemental nitrogen to various areas of putting surfaces that got a lot of traffic, whether it be edges from rollers or areas that golfers tended to go. And these last 2 seasons, the 2 seasons without the in-season top dressing, we've had to hardly do that at all. So again, that's a little bit anecdotal, but I think that the traffic resiliency of our surfaces has gone way up without that sand always being there and being sort of pressed into the leaves being pressed into that sand.
We got another question from TJ. This is nice and controversial. He says, Micah, I've seen a couple passing comments from you on Twitter and a bit here now about the need for needle tining for potential gas exchange. Is this a practice losing value, in your opinion, recently? Yeah, it definitely loses value, in my opinion, because there's 2 recent research articles, one from North Carolina on bent grass. Well, and the other one's not so recent, but I blogged about it earlier this year. It was published in the USGA's Turf and Environmental Research Online in like 2011 or something. I've blogged about both of those, so you can find it on my website. Both of those found that venting bent grass, so that the older one is from Virginia, I think from the Richmond area, and the other one is from North Carolina. Both of those very hot, stressful environment for bent grass in the summertime, and both of those venting did nothing. So then I'm like, why did I think this was so essential? Why did I think it's something that you should do like at least once a month, better yet twice a month during the summer? And if you have problems, if the grass is under stress, why did I think that it would be like something that you do instantly and then do it weekly or something until you nurse the greens back to health? And yet I'm seeing this research that says it had no measurable effect. So I start looking, and I'd gone to a seminar of milled angle-key in, I think in Dallas, maybe back in 2001, the GIS show in, I think that was 2001. It is getting late here, and I've been up since about 5, so my mind doesn't continue my train of thought always. But I think I'd been to a seminar on bent grass root zone management or something, I'd heard him speak with authority of the benefit that you get from venting, from needle tining. So I search all the academic turfgrass databases, the TGIF, the turfgrass information file at Michigan State. I search that for venting and milled angle-key, aeration, milled angle-key. And I mean, probably I'm totally missing it, and somebody's going to call me out and say, Micah, this is the paper you're looking for. So if you have that, please let me know, but I didn't find it. So he was talking about this, but maybe didn't have a lot of data to show it. So of course, air is important. Too much water is important. Lack of airspace is a massive problem. But in a sand-based root zone, I think we often are doing okay. And the venting maybe is just making us feel better, but it may not be having an effect. So
well, I
become skeptical.
I've been one who would vent needle tying based on, this idea that I was seeing some sort of surface decline that I was concerned about. And I was sort of reacting to that with the needle tying, thinking that that was going to help us. And, if it did or didn't, I don't know, but I've done it less the last 2 years because we've not seen the surface decline. And I've not then felt like that's a practice that we need to do. And again, that goes because, in my opinion, because we've had less sand on the surface during the season when we're intensely managing the greens, rolling, doing some combination of rolling and mowing every day. And I just haven't felt the need to do it based on a visual assessment of what the turf looks like. And it hasn't caused us any sort of issues. There is I guess, a statement from Jeff Whitmire. I don't disagree with that, I would say. We had a situation this year, actually. I was talking about infiltration earlier. We had a situation this year during one of our major club events in which we had not had rain for a number of weeks, and we were managing the greens really at a championship type level, hand watering, a little bit of overhead irrigation when necessary. But we had the greens exactly where we would want them to be to performing the way that we wanted. And we got not a lot of rain, but a sort of an intense rain shower during play on the last day that kind of came up out of nowhere. And the greens instantly became unplayable because there was, sort of what Jeff describes, almost like a lack of infiltration due to the intenseness of the managing and the lack of rainfall over the last 3 weeks. And so the greens quickly became unplayable because of almost puddling or surface water. But then it was almost like once the green accepted that moisture and the rainfall slowed down and infiltrated, then it continued to rain and it was not a problem. So I wouldn't disagree with what Jeff says, that there might be instances of that where you go a long period of time without any natural rainfall and you've been doing a lot of intense maintenance, and needle tying could help that sort of situation.
Yeah, I'm the wrong person to ask about infiltration because I'm just not a big fan.
Yeah.
I want to see where the infiltration is such a problem that you have to cancel tee times. And that's what I'm concerned about. And I just I agree with Jeff that you're going to get more infiltration if you vent, but like how much infiltration do you need? Do you have the infiltration blocked so much that tee times get postponed?
Mm-hmm.
I don't know. I mean, sorry, Kaya Keeper brought this up with me too. I encouraged him to stop punching so many holes also because I noticed the ball was snaking a little bit. That's part of something that you measure with the bobble test. Maybe in 2015 or something, the 2015 KBC Augusta tournament, he'd done, we both mutually agreed that it would be great to do some aerification. I forget if it was hollow tying or solid tying in June or early July. Then he rushed to get it ready for the tournament the last week of August. I was there measuring with the stimp meter, and I wasn't measuring the bobble test at that time, but I could see some snaking. And I noticed that, pointed it out to Andrew, and I'm like, I think maybe you shouldn't be punching so many holes. And his justification was, I'm really concerned about the infiltration rate. And he's really cut back on punching holes. And actually, he told me recently, I think he told me this year, that there just haven't been big issues with infiltration rate. So it turned out he was quite concerned about it, but then it turned out to not be a big deal. Because like if it rains hard enough that they get water puddling on the greens that you can't play, the whole course is unplayable. Mm-hmm. It's not that the greens would be unplayable and the rest of the course is playable, right? So
and this example that I gave of that tournament we had this year, where they quickly became unplayable and we had to stop golf. There was no lightning. It was really almost not even raining hard enough that that you would have had to stop play, but they had to stop play because this surface water was that is just such a rarity that I don't know if a person could ever or would ever want to account for that. And honestly, once, so yes, because the course was full and they were playing a tournament, all the golfers had to leave. They went in and they were in for an hour, hour and a half, or whatever it was. By the time they went back out, it continued to rain, and the greens were perfectly playable. So yeah, if I'm putting together the things that a golfer is going to vote on, let's say vote with, or the type of course conditions that they're going to see and make a note of and decide whether the course is good because of that, I think that infiltration would fall pretty low on that list, and it probably would be in some category that doesn't even come into account unless there's some weird situation like we had during that tournament this year. And that was the only time in 9 years that I've been here that we've had that situation come up. So I suppose, and to me, that wouldn't be enough of a reason to needle tighten on a regular basis to avoid that 1 in 9 years or 1 in 10 years type of situation. And again, and I'm not saying people shouldn't, I'm not saying people shouldn't do it, but as I made the statement earlier, if you're going to do it, then I think you should really know the reason you are, the reason for that, know what it is. If somebody comes to you and said, why are you doing this? Be able to tell them exactly why you're doing it. And if infiltration is one of those reasons, then I think that's just fine. But you have to assess whether that's a need at your course or not, I guess.
Yeah, I used to think I knew what it was accomplishing, which is why I recommended it. And now it's sort of like, yeah, you're punching a hole, you're sort of making it easier for water to go in, but does it do anything for the long-term health of the sward? I'm not nearly as confident about that as I used to be. All right. Chris, I thank you so much for your time. I think we covered your report and a lot more. That exceeded my expectations for the quantity of things we could talk about and the great advice and questions we got from people in the comments. So if anybody hasn't noticed, I'm trying to do a little bit more on YouTube, produce a little bit more video content. And one of the series, this is going to be a series, the ATC office hours, where I occasionally can meet with some people and talk about some technical things. I guess kind of like things that we'd have on a one-on-one conversation, like I do with many of you in the chat, but just make some of this information public and just put it out there for future reference. So it's good. I really appreciate it, Chris. Thank you. And
yeah, well, thanks for inviting me. I guess honored to be the first participant in the invitee in the office hours. But
I have some exciting news. I invited Tom Cook, and he said yes, but we haven't quite sorted out the time to do it. But yeah. I'm excited to talk with Tom Cook about lawns in the Pacific Northwest and turfgrass ecology. So hopefully he'll be here on office hours sometime.
It's a great venue. There are many of these out there, and podcasts and such, and some of them are great information, but they're over so quickly you sort of want more. And it's nice to do sort of these long form I think discussions, and some people may look at them and think, I don't have time for that. Here's how I oftentimes look at a podcast and I think, oh, it's 90 minutes. I don't have time for that. But then when I watch it, it's almost always worth my time. So, I also, and I know you do this, Micah, but I do with podcasts and videos, the option to speed them up to, a 1 1/4 speed or 1 1/2 speed is really a great way to be able to listen to more content in a shorter period of time. So if you look at something and it's 2 hours and you think, I don't have time for that, speed it up. Your ears will quickly and your brain will quickly adapt to that speed. And I think it'll save you time, which we all know is as valuable as anything.
Yeah, that's a great idea, and I do that all the time. I try to consume as much material because I want to know what people are talking about, what the new information is that's being shared. So I try to read and listen to as much as I can, and speeding it up works great. So that should do good with us because I think I don't talk at a very rapid pace. So I think people can ease. It probably sounds better when you listen to mine at 1.5 speed. And
Yep.
I'd like to thank everybody for joining in the chat and for watching this live. That was awesome. So thanks everyone. And I guess for everybody in the United States, have a great Thanksgiving week. That's a lovely holiday, and I'll be enjoying it in Bangkok.
Awesome. Well, get some sleep, Micah, and to everybody who was able to join in, thanks so much for listening, and hope you have a great day. Happy Thanksgiving.
All right. Thanks a lot, Chris. I really appreciate it. Bye-bye.